Yeah, I thought I plugged that in. Maybe I did not. There we go. All right, so in general, when we increase a concentration, if we increase a concentration, that is our stress. Will the equilibrium shift towards that stress or away from that stress? Okay, and if you did watch the video, I'm going to just do like a quick little thing here. So we have our reactant and we have our product. And if I increase concentration of reactant, okay, I'm going to put a little pulley here. Can you guys imagine a little pulley? Okay, and over top of the products, I'm also going to put a pulley, and there's my equilibrium arrow there. And this arrow goes up, and I'm going to make this like a rope that goes all the way across the pulley. Okay, and if the reactant is going up, that meant that I would have had to have pulled down on this side, yes? Which means that this would shift to the right. You really don't need to know this at all. This is irrelevant, okay? It's really the top part. I mean, the fact that this goes down, it doesn't mean the amount of product is going down, because obviously if you shift towards product, you make more product increases. But this just tells you the direction of the shift. If you like this little method, you can use that. If you don't like it, you can go through the thought of, if I increase the concentration of reactant, that means my forward rate increases. Yes? Which means that I'm making product faster than I'm making reactant, which means that I am shifting to the right. Okay? So if we increase a concentration, the system will shift towards the increase or away from the increase? Away from the increase. If we decrease a concentration, so let's reactant, product. If I were to decrease my concentration of reactant, and I put my little pulley system here, which way would the top part of the rope be moving? It would be moving to the left, which is away, towards the decrease. If you want to think of that in terms of rates, if I have reactants and I decrease concentration of reactants, then that means that my forward rate is going to decrease and my reverse rate will stay the same. So that should be a P, not an R. So that means I'm forming reactants faster than I'm making them, which means we are shifting to the left, towards the decrease. So there are many ways to figure out which way you are shifting. I like the visual one because it means I can, I think visually, so I can think about that really quickly. But you might we always shift away from an increase and towards a decrease. If you like just knowing the words, increase and away, those are both vowels. So it shifts away from an increase. Decrease and towards are both consonants. Although because I've underlined the T, it now looks like an I, so I'm going to undo that underline. They're both consonants, and so it shifts towards a decrease. And in fact, I should have written it away from an increase and towards a decrease, because increase away just grammatically is weird, but that's okay. Did I press record? I think I did. Yes, I did. Excellent. Okay, so this general principle was summarized by Monsieur Henri Louis Le Chatelier. Okay, Le Chatelier. And pardon me if my French is not that good, but at least I'm better than those Americans who call it Le Chatelier or Le Chatelier. Bah. Le Chat. Tell. Yay. Le Chatelier. So there's a little bit of an accent on the first one, and then the main accent's on the last one. Le Chatelier. Sort of. I don't know. It's hard to come up with a phonetic spelling.
Right.
Oh no, you don't. They don't need the arrow at all. Okay, just the diagram. Yeah. Okay, so Le Chatelier's principle says that when a system at equilibrium is stressed, the system will shift in order to minimize that stress. I'll probably get you to write this definition every day for the next week, because you need to know it, you need to understand it, you need to really get Le Chatelier's principle. Now, to be honest with you, if you understand everything from a rates perspective, the rates perspective is truly why things are happening. Le Chatelier is just a predictor. It's about as accurate as the pulley. Do you know what I mean? Like, the pulley isn't a real thing, but it predicts it. Okay? So what Le Chatelier would say in terms of a concentration is that, for example, if we increase the concentration of A, the system will shift to use up A. And bring its concentration back down. That's how Le Chatelier works. If you decrease concentration of A, the system will shift to make A to bring the concentration back up. And you can think back to those poor students in Mr. Weinberg's class last semester, because he had to be away for some time, and they were right in the middle of equilibrium and shifting in Le Chatelier's principle. And they had some random string of TOCs, most of whom were not chemistry teachers teaching them this. So you can be like, phew. As far as I haven't been away on a school day in 6 years. Yeah. So.
You take it right.
Oh, you know what? I'll take a Pro D day off.
Oh, not Pro D day, but like, do you just never get sick?
I haven't been sick in 6 years.
Do you just drink a lot of water or something?
I drink a lot of water. I try to eat a lot of vegetables. And I take every vaccine I can get. Like, I've had everything, right? I've had my measles updated because when I got my measles, it was back in 1972 or something like that, right? And it fades over time. I've gotten my shingles vaccine. I've got my shingles update. I've gotten my, because I've traveled, I've gotten hepatitis B, hepatitis A. I've gotten, I forget what other, pneumococcal something or other. I got yellow fever. I didn't get the full course because they were running low on it. So they're like, well, they're only giving quarter doses. And I'm like, damn it. I wanted to be immune to yellow fever forever. But that's okay. If I ever travel somewhere again, I'll get it again. So all those people out there who are like, vaccines are bad for you. I'm like, well, I don't know. I feel like having all those vaccines perhaps made my immune system go, I'm in overdrive and I'm going to fight things. But that's just speculation. That's not scientifically based either. So you can just, I don't know. Anyway, eat healthy. I also, if I'm out in the hallway and there's a lot of people, I'll hold my breath until I get to an area where there's like less people because I don't trust like all the air that whoever the heck is out there are breathing. You know, someone's walking down the hall coughing and I'm like, when I get somewhere where it's cleared up, right? Anywho, all right, write your reaction. Oh, the other thing is my family. We don't get together if one of us is sick because none of us wants to get the other sick, right? I live by myself. That makes it a lot easier because they're not bringing germs from anywhere else. But like, if I'm sick, I don't want to go visit my parents because they're 80 years old and I don't want to like make them die because they could, you know, they get pneumonia as a complication or whatever. And then they don't want to come see me because they know like it's stressful for me to be away from school because then I have to prep lessons and whatever. So we're all like, no, we're sick. We'll just talk on the phone. Okay, bye. Okay, so head to tail method of predicting the direction of a shift in response to a concentration change. You write your reaction. This is sort of like the pulley method that I was talking about. You draw an arrow representing your increase or a down arrow representing your decrease. And so if we use our little pulley method here, if I increase the concentration of H2, our pulley would go here. We would go over top of make sure you go over top of the equilibrium arrow. And it shifts that away. Okay, the arrow you shouldn't have, it's almost like, if you don't like the pulley thing, you could also do it like, you know how vectors work in physics? Always head to tail. Yeah, look at this, head to tail. Yeah, but if you prefer the pulley, you can use the pulley. All right, thank you. And then if we have a decrease, again, we're going to draw our line over top of the equilibrium arrow. And this one's going to go like that. It's going to go head to tail, right? So you should never see like this or like this. Never tail to tail or head to head. But if you prefer the pulley also works. So why don't you guys try these next two? Why don't you do the decrease in I2 and the increase in HI?
Do we ever combine them ever?
We will only ever give you one stress at a time.
So if we stress one, won't the other like?
The other will then shift. All concentrations will shift in response to one of them changing. Yeah?
You don't have to label the shift. on the.
It just depends what you are asked for. So if you're just asked which way does it shift, then you just have to write right or left, or towards the reactants or towards the products. If you are asked what then happens to the concentrations, we will look at that in a little more detail. Okay. So when we decrease 8I2, which direction does this shift? Does it shift to the right or does it shift to the left?
Right. Well, left and then.
When we decrease I2, it shifts to the
Right. And then down. No, it's left. Because like he's like left it.
it shifts towards the decrease. The decrease was on the left-hand side, so it shifts to the left. So if it doesn't matter, like I said, which method you use to figure out that it shifts left, as long as you do know that it shifts left. How about if we increase HI? What I'm going to get you guys to do is I'm going to have you vote either L for left or R is just you cross your fingers, R for right. Okay, so R for right, L for left. 5, 4, 3, 2, vote. And it's okay to be like, I don't know yet. There's some I don't know yet's because people aren't voting. Okay, so if we increase HI, and then we draw an arrow over top of the equilibrium arrow, this is ahead of an arrow here, okay? And so that means this has to be a tail, which means this has to be the head, which means we are shifting left. Or you can say we shift away from an increase, which also takes us, the increase was on the right. And therefore it shifts away from the right, which is to the left. Okay, so that's how Le Chatelier predicts it. All right. In each of these cases, Le Chatelier says, we made H2 bigger. Whoops. We made the concentration of H2 bigger. The system will shift to use up H2 to bring the concentration of H2 back down.
It'd be wrong for decreasing I2 if we do the arrow the other way towards the I.
For I2 here?
Yeah, we like instead of the arrow pointing left towards the I, can we do like the arrow towards the left?
Like this way?
No, like the arrow on the other side.
If we made the arrow go like that?
No, like it's the same line on the other side.
Yeah?
No, like. Bro,
You want to come draw?
I don't know.
So I've still got, do I still have this line?
Yeah.
Okay.
No, it's the line on the other side.
What? So am I dealing with this equation though?
Yeah.
Okay. What line?
So.
Where am I starting?
You're starting on the.
Tell me when to stop.
Stop.
Here?
No.
Come and draw it, please. Because I don't know where to draw the line.
Oh, yeah, no. I'll just show you from
Okay.
like that. Is that correct? Or
Oh, if we go like this.
yeah. That's,
Well, did we go over top of the equilibrium arrow?
oh yeah, we did it.
No, we didn't. So you're just looking at reactants and reactants. So you haven't, it always, your line, if you're using the line method, it should always go over top of the equilibrium arrow. Yes? So it always has to pass over top. Must pass over the equilibrium arrow. That was a good question. It just took me a minute to figure it out. Yeah? Okay, very good. And then, for example, over on the decrease in HI, what Le Chatelier says, and sometimes I just call it Le Chat. So if you're like, I don't want to say Chatelier because that's like way too word, Le Chat. Okay. Le Chatelier says, what did we do in this example here? Whoa, that was supposed to be a highlight. What did we do in this example? We decreased the concentration of HI. Therefore, what does the system do? Shifts. To do what? Remember, Le Chatelier said, if we stress the system, if we do something, the system shifts to minimize that stress. So the system says, you made HI small. I don't like that. I'm stressed. What is the system going to want to do? You made it small. I'm going to make it big. Okay, so the system shifts to, in this case, make more HI to bring the concentration of HI back up. Okay? But remember, Le Chatelier's principle is not a very good explanation. It just tells you how things happen. But you will sometimes be asked to explain a shift in terms of Le Chatelier's principle, in which case you would use this kind of reasoning. Okay? I actually disagree with the fact that we should be using this, but because it's not really the root cause. The root cause is the rates, right? And then who cares if you use Le Chatelier and you use the pulleys or you use whatever. But anyway, alrighty. We good? Okay. So, explaining in terms of rates versus explaining in terms of Le Chatelier's principle. We just did some explaining in terms of Le Chatelier's principle. The day before yesterday, we did some explaining in terms of rates. So consider the following system. We have 2NO plus H2, there's our reactants, and then in our products, we have N2O plus H2O gives 36 plus 36 kilojoules. In which direction does the equilibrium shift when some NO is added to the system? So I would like you to try and explain that to your partner without looking at it at the answer sort of thing in terms of Le Chatelier's principle. So you can say what we did is this. What the system does is that.
Oh yeah, fine. Yeah, so it's just a kind of, you know, therefore these. Yeah, like this one and this one and this one. I sure. Because like when probably you're right. Technically we do that. I think you're right. I think you're right. Because there's something like it's in the reaction that something you down.
Okay, does anyone want to give a try explaining it? Everybody shy? Yes. To the right. Yeah, it's going to shift to the right. Why does it shift to the right? It's an increase, so it shifts away from the increase. Okay, so the stress to the system, this is what we did. Whoops. I can't write today. What we did was an increase in NO. Therefore, the system is going to try to decrease NO. So the system is going to shift to the right. In order to, is it going to want to use up NO or make NO? Use up NO in order to bring the concentration of NO back down to close to its original value. So that is a Le Chatelier explanation. This is a Le Chatelier explanation. What did we do? What did the system do? In terms of rates, try and explain that to your neighbor. Why does it shift right in terms of rates when we increase the concentration of NO?
Oh, yeah. Yeah. The reverse rate is gonna, yeah. Because your punishment, we even don't help it.
Okay, so we can do this visually with arrows, or we can do it verbally with sentences. When we increase the concentration of NO, what does that do to the forward rate? It increases the forward rate because there are more reactants, therefore there are more collisions. Okay, so when NO is increased, the forward rate increases due to an increase in the number of collisions. Because this is rates, make reference to collisions. between reactant particles. What happens to our reverse rate? It stays the same. Because the concentration of the products did not change. And that makes our forward rate what in comparison to the reverse rate? Faster or slower? Faster. And if that is the case, are we making reactants or products faster? We're making products faster than we are using them up, which means the system is shifting. I'm going to make a change there. I'm going to fix that. It's not a big deal, but the system shifts right. And our reaction arrows in terms of rates, forward, reverse. And sometimes if you're asked in terms of rates, just drawing those arrows can be really powerful because you can just see, oh my gosh, I'm going forward faster. That means I'm shifting to the right. Yeah, so sometimes just drawing those arrows can be really helpful, even if you're not asked to do it. All right, do you guys want to try this one? Okay, try this one. In which direction does the equilibrium shift when some H2 is removed? And in this case, you're going to explain in terms of the Chatelier's principle. What goes in that first blank? Stress. Remember, Le Chatelier's principle says when a stress is applied to a system at equilibrium, it shifts. So you should always say, what was the stress? What was the shift? What did we do? What did the system do? The stress to the system was what? A decrease in concentration of H2. Therefore, the system shifts which way? To the left. Okay, I can use my arrow technique if I like, or I can say it shifts towards the decrease. The system shifts left in order to do what? Make more H2 and bring the concentration of H2 back up. Very good. Okay, you should be practicing how to write these explanations. Yes? Just straight up writing it without filling in the blanks. Yeah, there's going to be there's going to be like practice exercises in here, okay? All right, try this one while filling in the blanks. When H2 is removed from the system, explain the shift in terms of rates.
like straight up remove, or just
Well, when some. And I might call names for this one to fill in the blanks. That'll be fun. So if you don't know and your partner doesn't know, go find somebody who does. Or you can call me over. You can be like, hey, over here, Miss Spence. Anyone? Over here, Miss Spence?
page one.
Okay. Oh, okay, don't do that. All right, here's a rule to run you. When you're in my classroom, you may not play video games. Otherwise, I'll give you a bad mark on your peer tutoring. Because I understand that there's not sometimes a lot for you to do, but you could be working on your AP chemistry or your calculus or whatever. And you're one of your things is you're supposed to be setting a good example for these young people out here.
Yeah.
Okay. So when H2 is decreased, are we ready? Anyone need more time? You do need more time? Okay, more time is yours. Are we ready? Another second? Yeah. Good, you got it. By the way, if you're just waiting for us, you could try the exercises. Okay, we're going to start filling in some blanks. So when H2 is decreased, what happens to our forward rate, Coco? It what, sorry? Decreases, yes. And why is that, Tarim? Yeah, the number of collisions between reactant particles decreases.
But how could we just write less collisions in reactants?
Less collisions in reactants. Perfect. You can make it as short as you like. By the way, just so you guys know, chemistry 12, point form is good. You do not need to write in full sentences.
Wait, so
you do not need to write in full paragraphs.
Wait, on the test,
Yep.
Definitions, we can literally just.
You can literally put point form, yes.
So for maybe what is a mechanical,
Yep.
We can do that?
Yep.
Oh my God.
Yep. Okay? It just makes your life easier, right? So you don't have to be like, oh, here's a paragraph, here's my introductory sentence, here's my conclusion sentence. No. Just get to the meat, all right? Make sure, though, that I'm not picky about grammar unless your grammar makes your answer wrong. Do you know what I mean?
Yeah.
Okay? If your grammar is like all over the place, but the meaning is there and I can see it, but if you've said something that makes it wrong, then I have to say, oh, sorry. Okay. What happens to our reverse rate in that moment when we decrease the H2, Isabella? The reverse rate stays the same. Because we did not do what, Eric? We did not change the concentration of the products. And we'll now do since the whatever is whatever, then the whatever. Kiona. Since the reverse rate is faster than the forward rate, if you chose to say the forward is slower than the reverse, that would also be fine. But usually we talk in terms of which is faster. It makes it a little easier to understand. But the other way is fine too. We are making what faster than we are using it, Alexander?
We're making reactants.
Reactants faster than we are using them up, and therefore the system is shifting left. What would our reaction arrows look like? Which one would be longer? Chloe. Which one, sorry? The one going to the left, yeah. So you would have this one longer than that one. Yay. Okay. here is a summary. So when you're answering the questions in the exercises, you can be like, okay, number 1, I should say what the stress is. Number 2, I should say which direction the equilibrium shifts. And number 3, I should say why it shifts that way in order to either produce something to bring it back up or to use up something to bring it back down. All right, and that takes care of Le Chatelier. Explaining in terms of rates. Explain why the forward rate changes or doesn't change, right? In terms of collision theory, whether it increased or whether it decreased or whether it stayed the same. I need to fix this. Fix. Do the same for the reverse rate, except for you'll say product particles instead of reactant particles. Compare the two rates. Therefore, this rate is faster than that rate. Then say what you're making faster. And then say which means the equilibrium is shifting whatever direction it is shifting. Okay, that is a script that you can follow. Do you have to follow that script exactly? No, but you need to get the essence of it. And I find that often students in grade 12 need the script to get the essence. But if you feel you can, go off script, that's fine, as long as you've got everything in there that you need. Okay? So there are some exercises here on pages 35, 36, 37. And actually, I would like to give you some time to do them so I can come around and see how you're doing. Okay, so why don't I let you do some of that right now? Okay. Zero, zero. Yeah. We need to stay out of the ball. This is why I find it very stressful. Like I get all nervous. I'm like, ah, turn it off. Yeah. Is this one? Not in reverse rate. That makes sense. So yeah. So we always know these reactants. It's always okay. And reaction.
So what is the first react? Stay there for, which goes faster. Yeah. This takes care of the same thing, so you could say one for the first react, or you could say one for the I would probably shift. Whereas the Chatelier, it shifts that with the first. Yeah. 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 So the last quiz for this one.
Yeah.
So to make that for the change. Okay. All right. Kieran? Yeah? Yeah. Yes. I'm just being realistic. So you are taking over my application, which is fine. Oh, well, I'm it. It's fine. Right, so I yeah. For example, but it's okay. You're in terms of race, you're like, okay, that's fine. Okay. Okay, wait, oh, what is it called? Oh, wait, no, we are living. Sure. Yes.
No.
They're all one. So this is on space level. Yeah, it just saves you a lot of time. Oh, yeah. This is. Pressure.
Hey, you gotta go up and figure it out here. What? Well, what question you was asking?
Do you know what I mean? Because we've got that already. Like in order to get it, it's pretty hard. Down here, and in order to do so, it's all it's so it is here. Yeah, and then right here, it is. Yeah, so. Yeah, well, here, what I want to say is that this road is right. And when Emma was out, it's like. Okay, so that's just. No water. Sorry. Wow, that's everything I feel like I was about to distract.
What do you do? Like, go to the beach.
On their one.
Well, yeah, I appropriate for that. Why do you have to know?
Okay, so let's do the Chatelier task. You're gonna say what the strategy is.
You know, right now.
I have two shares.
Right. So I'm going to.
Yeah. So. Yeah. No, no worries. It's all good. I'm like, think about it last year. Yeah. All right, that looks good. Okay, and now you can start talking about grades. First grade. Right back to the schedule. Yeah. 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 Yeah, we usually run that's fine. You're good.
How?
Hi. That's it though. Actually, so like how no, that wouldn't here. So you're allowed to do that. You know, needs this is like flat. Okay. So it should go. Well, these technically should be like one of the others. Yeah. So, I mean, these there, which I think. Okay, but this is there we go. Yeah. Yeah, for sure. Yeah. 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 And so starting at a yeah, before my yes. I would put them as close as possible. Yeah. And often when I make one thing, I follow the word dash, but it doesn't matter. And then you know that thought faster. That's easier to tell, yeah. Okay. And then they go to our yes. Yeah. You don't have to be perfect, but
Yeah, lots.
they don't have to fight, right? Technically, they should, like, they should literally be one on top of the other, but like, so when if I have a too much.
Because like it's
Oh, yeah.
like because these actually balance.
You're working like that. No, who's it? Yeah. Yeah. Yes. Yeah.
No, but I like mixed them both.
Okay. So as we first.
You probably know something. Yeah.
So. Same. So I would think twice as much.
Or maybe you can do it. Yeah, maybe. Okay, yeah, do it. I'm not sure. I know. So what did you learn?
Oh, yeah, yeah, yeah.
I did not.
Oh,
What? See, I don't know. But you know, that's you said.
Yeah. Thank you, Miss Mary. You're welcome.
You know,
Perfect. Well, I didn't think you would. I know.